Hi Matrix, welcome back to another one of our video lessons. So today we're going to carry on with perimeter, area and volume. So we're on page 180. So we're going to start with unit 1, which is perimeter. Then we're going to do area unit 2 and volume unit 3. Okay. Alright, so let's first start with unit 1, perimeter. So in Matric you guys will be required to work out perimeter, area and volume of different things, right? Whether we'd be painting a house or trying to figure out how much paving bricks we'll need or how much water we need to fill up a swimming pool or things like that. So this is definitely coming up in your end of year exam, so you better learn how to do this. Alright, so perimeter is easy. Perimeter measures the outside distance of a shape. Okay, so I think of a perimeter as going for a run around the block. Okay, so you're not working out what is the area of the block, you're working out what is the distance around the block that I'm running around. Okay, so there's a few formulas to note. So your perimeter P, okay, I don't know if you can see that now, it's a bad pen, let me use another color. Okay, so our perimeter P, if we have a rectangle, okay, which has length L and breadth B, okay, so our perimeter is going to be all the sides added together. So there's two lengths and there's two breadths. So it's 2L plus 2B. Okay, that's the perimeter for a rectangle. Okay. Right. If we have a circle, the perimeter of a circle is known as the circumference of the circle. Okay, remember the only measurement of a circle that's really important is the radius of the circle. So the radius is a distance from the center of the circle to anywhere on the circumference of the circle or the edge of the circle. Okay. Now, if we're talking about diameter, that is double the radius because the diameter goes from one side of the circle through the center to the other side of the circle. Okay. So radius is half of the diameter. Okay. All right. So now what is our perimeter or circumference? Let's call it C for circumference. So our circumference is 2 pi r. Okay, so that's the formula, 2 pi r. 2 pi is 3.14, or you have a button on your calculator, and and r is your radius of the circle. Okay. Also, for the circumference, we can use the diameter. So instead of saying 2 pi r, remember a diameter is 2 radiuses. So here's our 2r. Okay, so instead of the 2r, we can write the diameter. So it's just pi d. Okay, so you either use diameter, so it's pi d, or 2 pi r if you have the radius. Okay, both formulas are really exactly the same. It's just diameter is twice the radius. Okay. All right, so for perimeter, those are the formulas that we are using. Now, perimeter of a triangle, there's nothing special about it. Just add the three different sides together and then you have your perimeter. Okay. All right, cool. So sometimes what we'll do is we'll give you composite shape, meaning that the shape is made out of two pieces, something like this. So we'll give you half a circle on each side with sort of a prism in the middle or a rectangle. And we'll say, right, what is the perimeter of this? Let's say it's a running track, right? How do we work it out? Okay, well, you've got to realize that there's half a circle here and half a circle here. So if we slice it over there and put the two circles together, we're going to get one circumference of the circle. Okay, so what we really need is we need this length over here, that length over there, and the circumference of two half circles, which is just the circumference of one full circle. Okay, so guys, that's the worked example on page 180 that's talking about this exact kind of thing. All right. Okay, so let's start with exercise 1. I'll start it off with number 1, and you guys are going to do the rest for homework. And then we're going to move on to the area. Okay, so I'm on page 180, exercise 1, number 1. A wheel on a car has a 65 centimeter diameter. The car was driven 80 kilometers in 55 minutes. Hint, the car travels a distance equal to one circumference of the wheel every time it completes a revolution. Use pi equals 3.142. Okay, so there's a car, it drove 80 kilometers in 55 minutes. And also they tell us that the diameter of the wheel of the car is 65 centimeters. Okay, cool. Let's continue. So 1.1, it says, how far does the car travel in one revolution of its wheel in meters? Okay, obviously if we have a wheel and it starts here and then we're driving, one revolution of the wheel will cover the circumference in distance. Okay, so if you don't believe me, take a ball or something round and roll it along a flat surface and time where one so what I'm trying to say is, let me just get something to illustrate. Something round. Okay, so let's say this is our wheel, right? Our wheel of the car. And what I'm going to do is I'm going to make a mark. There's my mark. So what I'm going to do is I'm going to roll this wheel on, say, this is my road and that's my wheel. Okay, so there's the black mark. What I'm going to do is I'm going to roll it one revolution and then I can measure how far does it actually travel. So if we carry on, you'd see it would end up somewhere here. So one revolution would pretty much cover about that much distance. Okay, so we're going to use that and the formula for circumference to find out how far does the car travel when it completes one revolution of the wheel. Okay, so well, let's work that out. Remember, our circumference formula equals 2 pi r. Okay, in this case, they give us a diameter. Okay, so with the diameter, we can use the other formula. So instead of saying 2 pi r, we'll just say pi d. Okay, pi is 3.142 multiplied. What is the diameter of our wheel? It's 65 centimeters. Okay, so if we write 65 here, we are working in centimeters. Okay, in later questions, they'll ask us about kilometers, so we must remember what is going on here. So with one revolution of the wheel, the car is going to travel that much. Okay, so let me just get a calculator and work that out. Okay, 65 times 3.142 equals 204.23. Okay, and this is centimeters. So when the wheel turns once, we have traveled 204.23 centimeters. Sorry, guys. Okay, right, let's continue. Oh, actually, the question asks us in meters, so we actually have to convert this to meters. How do we go from centimeters to meters? We divide by 100. Okay, so we divide by 100 here. We're going to move the comma 2 places to the left. Okay, so it will be 2.0423 meters. Okay, so just over 2 meters. Right, 1.2. How far does the car travel in 3/4 of a revolution of its wheels? Okay, so if this is how much it travels in one revolution, how much does it do in 3/4 of a revolution? Well, let's multiply this amount by the proportion of 3/4 and we'll find out. So 3/4 multiplied by 2.0423 meters would equal to, let me quickly do that. Okay, so I get 153.1725. 153.1725 meters. Okay, so in 3/4 of a revolution, it travels that much. Guys, I can ask you, how much would it travel in a third? How much would it travel in 2/5 of a revolution? The answer is always the same. Take your full revolution and multiply it by whatever proportion I give you. And that's the answer. Okay. 1.3, how many meters did the car travel in the 55 minutes? Okay. So they told us that the car traveled 80 kilometers in 55 minutes. So we really just have to convert 80 kilometers to meters. Okay. So 80 kilometers equals, how do we go to meters? We multiply by 1,000. Okay, so 80 kilometers is 80,000 meters. Okay, actually I want to keep this number, this 2.0423. We're going to need it. Okay, that was one revolution. Okay, so we've done that. 1.4. How many times did the wheels complete a revolution in the 55 minutes? Okay, so in the 55 minutes, the car was traveling and it traveled 80,000 meters. Okay, each revolution of the wheels accounts for 2.0423 meters. Okay, so they're asking us, in the 55 minutes that the car drove 80,000 meters, how many revolutions of the wheels did we have? Well, to find out that, let's take our total distance, 80,000 meters, and divide it by the distance covered by one revolution. So we're going to say number of revolutions equals 80,000 divided by 2.0423, and that would equal... Sorry guys, the cat keeps coming in and out, and yeah. Okay, so let me just divide that. So 80,000 divided by 2.0423. Okay, so I get 39,171. 39,171.52. Okay, and that is revolutions. Okay. Now, guys, let's think about this, right? You know how we round off units in Maths Lit, right? So when we're talking about cars or people or chocolates or whatever we are counting, it's always rounded off to the nearest unit, okay? So here they asked us for how many revolutions we would cover. Is it okay that we have 0.52 of a revolution? Yes, it's okay, because we can go halfway around the circle and stop there. That no one told us that, you know, wheels have to turn only in whole round turns. Okay, I mean, of course, round turns, but whole revolutions. Okay, right, so that is 1.4, 1.5. How many times did the wheels complete a revolution every second on average? Average revolutions per second. Okay, so they want revolutions per second. Okay, so that is essentially speed, but we are counting it in terms of how many revolutions happened. Okay, so we have this many revolutions happening in 55 minutes. We want to convert that to number of revolutions per second, not per minute. Okay, so all that we have to do is take the number of revolutions. So this 39,171.52, okay, and divide it by, so remember, speed equals the total distance that we cover, okay, over time, right? But the total distance that we cover now is not really distance, it's the amount of revolutions that we have. But that translates to distance because one revolution is 2.04 meters, okay? So this is essentially also measures distance. So we are counting the speed of the revolutions happening per second, okay? So that's how many revolutions happen. How much time is passing while that is going on? It is 55 minutes. Okay. But now they ask us for revolutions per second. So we need to take these minutes and convert them to seconds. Okay. How do we convert minutes to seconds? Well, we multiply by 60. So that's all we have to do at the bottom here. So our S, or speed, equals 39,171.52 divided by, now 55 times 60 seconds will give us seconds, and then we can do that on our calculator and see what the answer is. Okay, let me do that quickly. So we have 39,171 0.52 divided by 55 and 60. Okay, so what I get is 11.87. 11.87. Okay, 11.87 what? Okay, the answer to that question is what we started with. What are we counting? We're counting revolutions per second. Okay, so here it was minutes, then we converted it to seconds. So it would be 11.87 revolutions per second. Okay, cool. So every second the wheels are spinning 11 times. Okay, so that is that's quite fast. All right. So guys, that is 1.5. That pretty much covers most of the perimeter questions I can ask you. Okay, it's got speed, time, and distance. It's got working out how much distance something covered. Another good example is the worked example where we give you a particular shape and you need to work out the perimeter of that. So the rest of exercise 1 is for you guys. Number 2, 3, 4. Okay, so just 2, 3, and 4. Okay, so that's practice on perimeter. And now we're going to continue on to area. Okay, guys, with the area, I'm just going to cover the different area rules for different shapes. And you guys are going to do exercise 2 and exercise 3 for homework. Okay, so let's cover area. Now, when we measure distance, it's a linear measurement, right? It's from A to point B, okay? So it could be a straight line, and that only has one dimension, distance, okay? So, or meters or centimeters or whatever it is. But now, as soon as we start measuring area of something, okay, we want to know what are the square units inside this area. So square meters or square centimeters. And literally, a square meter is a 1 by 1 area, which looks like this. Okay, so that is 1 square meter. Sorry, my Coke is running out. Let's try another one. Okay, guys, so that is a meter squared. So if I have a bedroom that is 3 by 3, it looks like that. Okay, so that is a 3 by 3 bedroom. Okay, and so if I go, let's say I need to buy some paint and I go to a paint store and I say, right, I need to paint my house. The first question they're going to ask me is, how many square meters are you trying to cover? What is your surface area that you're trying to cover? And if you don't have that answer and if you haven't worked it out, you can't really get the paint. You know, I mean, yes, you could, but you're going to have either too much or too little, and you're going to waste money. And the shop is probably going to try to sell you a bit more than what you actually need. Okay, so it's always a good idea to work out your surface area and then go to the shop and say, right, I have 203 square meters. How many liters of paint do I need if I need to do 2 coats? And also I need to account for, say, 5% spillage or something like that. Okay, so that's the kinds of questions that you're going to get in this unit. Okay, right, so an area of a rectangle. Okay, let's go through the different areas. So we can have an area of a rectangle which looks like this. All right, so it's a length times breadth. So area equals length times breadth, and that is always in square units. Whatever units I give you, it's those units square. If I give you a question with no units at all, and you have to answer and you have to find the area of the shape, you're going to say there, let's say you get 5, and you're going to say units squared. Okay, whatever those units are, we don't care. They just have to be squared. Okay, so the area of a rectangle is just length times breadth. Okay, easy. Okay, now we can have a right angle triangle that looks like this. Okay, now the area of a right angle triangle is a half base times height. Okay, now guys, when you're working out areas of triangle, remember, the height is always perpendicular to the base that we have. meaning that there's always a 90-degree angle between the base and the height that we are measuring. So when we measure the area of a triangle, we never use the longest side, which is known as the hypotenuse. Okay, so just keep that in mind. It's a perpendicular height multiplied by the base and multiplied by half. If you guys want to figure out where does this formula come from, because it looks very similar to that formula, it just has a half. Let's say we have this triangle with length L and breadth B, same as that rectangle there. Well, if I take a diagonal over here and cut it in half, I'm going to get half the area, right? So the full area of a rectangle is length times breadth, but an area of half of that, well, the area of half of that rectangle, which is just a triangle, was going to be half breadth times height, which is the same two dimensions that we used earlier. Okay, that's all that is, right? So if you ever forget this formula, imagine just saying half of the triangle, half of the rectangle. Okay, now a little bit more complicated version of a triangle could be something that doesn't look just like that with a right angle, but it will have another piece over here and it will be a right angle triangle like that. So that's also a right angle and that's a right angle. So the formula is still the same. We use base, which is this, the whole base, and we use the perpendicular height, which is that. Okay. Again, we are still not using the hypotenuse of either one of those triangles. Okay, so doesn't matter what right angle triangle you have, we can always find the area by saying base times the perpendicular height. Okay, so that's rectangle, triangle, right? The next one is a circle. So like in the perimeter, the only measurement for a circle is a radius r. Okay, that's it. So the area of a circle is pi r squared. Pi is the universal constant 3.142, and r is our radius of the circle. Guys, be careful, do not use diameter here. Okay, you cannot, there isn't another version of this formula where it uses diameter. Okay, so when you're plugging this in, make sure you have radius. So I could say there's a circle with diameter 2, what's the area? Okay, and a lot of you will be tempted to put a 2 in there, but you need to divide the diameter by 2 to get the radius, which is 1, and put it into the formula there. Okay guys, so that's the areas of our general shapes. That's what you have to know. We're not going to go to any other shapes. We're going to stick with these. Now, with the different types of questions that you're going to get, some of them say estimate the area of what something looks like. And we give you a grid like the worked example and like exercise 2. Okay, and there you just use your common sense to approximate what the area might be. We're not trying to get it exactly perfect, but you want to get a nice good estimate, more or less what it would be. Okay. Right, so what I want you guys to do is so what I was trying to say is that there's a place where they will say estimate, and there'll be questions where we'll say calculate. Okay, so calculate is exact, estimate, you're trying to roughly find what it is. So you'll see as you work through these exercises, the first one is going to talk about estimating, and then exercise 3 is going to look at calculating. Now for exercise 3, you're going to need to use the theorem of Pythagoras, right? So Pythagoras, let me quickly show you that. So Pythagoras, I'm sure you already know, but it talks about right angle triangle, right? So in exercise 3, there's a question that asks, what is the dimensions of the roof? Okay, so let's say this is our house, right? And that's our roof, and then the roof runs that way. Okay, and then there's a house that looks like that. So what we need to do is we need to find the area of this roof. But to get the area of this roof, we need to get this distance of this right angle triangle here. Okay, remember, if I give you the measurement, say 2, 3, like that, and it's a right angle triangle, we can find the longest side, or the hypotenuse, by using the formula for Pythagoras, which basically says the hypotenuse, which is c squared, equals to a squared plus b squared. A squared and b squared are the other two sides of the right angle triangle. So in our case, our c squared will equal a squared, which is 2 squared, which is 4, plus b squared, 3 squared, which is 9. Okay, that will give us 13, right? Now we need to find c, not c squared. Here we have c squared equals to 13. So c squared equals to 13. How do we find c? Well, we have to square root both sides. Okay, the square root cancels with the square to give us the c, and that is root 13, whatever that might be on the calculator, or you can even leave it like that. Okay, so this distance here is going to be root 3. Okay, obviously it's not the right distance, or I don't think it's the right distance. I think I just made up those values. Yeah, I did make up those values, but they're actually the same values. So yeah, guys, work through it. So the answer there is root 3. Lucky guess. All right, guys, so that's that. We're going to stop there for today. So what I want you to do is the perimeter, exercise 1, and unit 2 area, I want you to do exercise 2 and exercise 3. And we'll continue with exercise 4 and then the rest of the surface areas and so on. All right, cool, guys. Thank you. I hope you enjoyed it, and I'll see you next time.